the very same kind of problems, only we are on page 42 of our notes. We are on part 4, and we have C, D, and F to go. And remember, we left C, D, and F because they are all in radians. So we're going to go to mode on our calculator, and we're going to set it in radians. Okay, and now we're just going to type this stuff in. So problem C says cosecant. To type cosecant, you're going to do 1 divided by sine. That's what cosecant is. Remember, we're memorizing our yellow sheet. So cosecant 5 pi over 6t. So we are literally going to type 1 divided by sine 5 pi, and use your pi button, divided by 16. And you should have come up with 1.2027, if I round off to the 10,000th like it says. Everybody get that? Easy? All right. D, cosine pi over 9. Nothing fancy there. Cosine pi divided by 9. That's 0.9397. Cotangent 2. How am I going to put cotangent into my calculator? 1 divided by tangent. Yep. And that's not 2 pi, that's just the number 2. So 1 divided by tangent 2, and that's negative 0.4577. We're going to come back to our calculators in just a second, but first we have this little part here where we're not to use a calculator. So everybody good on that? Now, remember, your calculator is now set in radians, so whatever we do next, if we need it in degrees, we'll have to change it back, right? So just keep that in mind. You always have to make sure you're in the right mode. Okay, now the next question says, the sine of theta is 1/2. And your job is to find the angle that has a sine of 1/2. Now your calculator will do this for you, but we're doing it without a calculator. So here's what I want you to think about. I want you to think about your triangle here, your standard position triangle. Remember our angles here in standard position. And I have no idea how big that angle is, but I know that its sine is 1/2, right? Well, sine is opposite over hypotenuse. Those two numbers look familiar to me. If that's a 1 and that's a 2, this one's going to be a √3. And I automatically know that's a 30, 60, 90 triangle. And since the angle I need, you're always going to be looking for the angle at the origin. Since the angle I need is across from the 1, I know that angle is 30 degrees. So theta is 30 degrees. So you just worked it backwards. That's backwards of what we were doing the other day. Now I'm giving you the function, and you are telling me the angle. Okay, let's look at the next one. The next one says the secant. Okay, so I'm going to draw my triangle here in standard position. Here's my angle I'm looking for. And I know that the secant is √2/1. All of the trig functions are fractions. So I like to go ahead and put it over 1 if it's just a regular number. Now, secant. Secant is reciprocal of cosine. Cosine is adjacent over hypotenuse. So secant must be hypotenuse over adjacent. So hypotenuse over adjacent is my secant. Well, again, if we're doing this with no calculator, these angles have to be special. 1, 1, root 2, right? And how big is that angle? In a 1, 1, root 2 triangle, that angle is 45. So the answer to the question is 45 degrees. Oh shoot, I'm supposed to be doing this in degrees and radians. Sorry. All right, so let's go back and clean that up. So 30 degrees. How many radians is that? Let me throw this out at you, pi over 6. Does that make sense? What's pi? 180. And isn't 30 a sixth of 180? So that's how I got pi over 6. But if that's stretching it, because we're just learning, so if that's stretching it too much, pi is to 180 as something is to 30, right? We can always change it that way. But you can also think about it as 30 is a sixth of 180. So it's going to be a sixth of pi. What about 45? Can you think about 45? How many radians is 45? Well, if it's not processing, pi over 180 equals what over 45? So x equals 45 pi over 180. 9 goes into both of those. 9 goes into there 5 times over 20. Pi over 4. Does that make sense? Yeah, because 45 is 1/4 of 180. So it's going to be pi over 4. All right, see if you can figure out C on your own. C says we know the tangent is root 3. And I'm going to think of that as root 3 over 1. Oh, shoot. Sorry about that, guys. Is that better? So did you draw, hopefully, your standard position triangle? Tyler, you want to take that off for me? Thank you. And I don't know how big this angle is, but I'm going to figure it out. Did you? What did you get for that angle right there? 60. If you got 60, you are exactly right. How do we know? Well, the tangent is opposite over adjacent. Opposite over adjacent, right? There's your special right triangle. Across from the 1 is 30. So if this angle is 30, then this one's got to be 60. Perfect. Did you get that in radians? How many radians is this? Pi over what? Not pi over 2. Pi over 3. Because 60 is a third of 180. Okay, one more. Cosine 1/2. Cosine is 1/2. I got 60 again, did you? Now, all of these problems, if you're doing them without a calculator, are going to have to be 30s or 60s or 45s, right? Otherwise, we'll do them on our calculator, and we'll talk about how to do that later. But right now, we're doing them by hand, but they're all going to be special. Okay, everybody got it? Okay. So now we're moving on to part 6, which we're back to a calculator again. And now we have more right triangles, but they aren't special ones. They're just random triangles. And we are going to find lengths based on the scenario that we've been given. So this is 57, this is 32, and we're looking for y. So we have a right triangle. That's critical. We have a right triangle, and our job is to find the length of the hypotenuse. Now I want you to stand back. Here's the angle that they gave me. Now I could figure this one out, right? We could all figure that angle out, but we don't need to. We'll just use the one they gave us. With regard to that angle, which side is this? Opposite, adjacent, or hypotenuse? Opposite. This is opposite. And with regard to that angle, which side is this? Opposite, adjacent, or hypotenuse? Hypotenuse. So in this problem, you have been given information about the opposite side and the hypotenuse. So which function, sine, cosine, or tangent, are we going to use? Sine. SOHCAHTOA. You can write that down at the top of your paper to remind yourself. SOHCAHTOA. So we have opposite and hypotenuse. So that's going to be a sine problem. So we're going to write sine angle equals opposite over hypotenuse. So there's your equation. It's the sine of the angle equals opposite over hypotenuse. Now we're solving for y. So let's multiply both sides by y. And then divide. So y equals 32 divided by the sine of 57. Is everybody following all that? So now I'm going to go to my calculator. I'm going to make sure I'm in degrees because 57 is a degree measure. So I go to mode and change over to degrees. That can be an absolute killer, people, if you don't remember to check your mode. So get in the habit of checking your mode. And then type 32 divided by sine 57. And did you get 38 point, how am I rounding, 100? 38.16? Easy. How did we know we were going to use sine again? Why didn't I use tangent or cosine or something else? Why did I pick sine?
You're the opposite.
Because the numbers or the sides in the problem are opposite and hypotenuse. Exactly. So that's what we're going to focus in on. Which sides do we have? All right, so here we go. Another situation here. I know this angle is 71 and this side is 18, and I'm finding that side. So again, I'm just going to use the angle they gave me, which is right here. So with regard to that angle, which side is this? Opposite. Which side is this? Adjacent. So this is going to be what kind of a problem? Sine, cosine, or tangent? Tangent. So I'll say tangent angle equals opposite over adjacent. Multiply both sides by x. And divide by the tangent. So 18 over tan 71. I know I'm in degrees because I just switched it, so I'm just going to type it in. 18 divided by tan 71. Did you get 6.20? Okay. Now comes the real reason we're doing all this. Now we're going to do some actual problems by setting up our own picture and labeling it, and then using basic right triangle trigonometry. So here we go. We have a squirrel sitting in the top of a tree that is 52 feet tall. So here's my squirrel in the top of the tree that is 52 feet tall. He is looking at a nut on the ground. So here's the nut on the ground. The squirrel's looking down at the nut on the ground. His angle of depression is 23 degrees. Now, I know you learned about this in geometry, but I want to make sure we're straight on this. Angles, okay, if I look straight ahead, I'm looking straight ahead. The angle that I tilt my head up through is called the angle of elevation, and the angle that I tilt my head down is called the angle of depression. So nowhere in that triangle is there an angle of depression. The angle of depression is right here. The squirrel looks straight ahead and then looks down. That's the angle of depression. So I really don't want that angle because it's outside of the triangle. But if that angle is 23 degrees, isn't this one 23 degrees? Because these are parallel lines and these are alternate interior angles. So you will never, ever, listen to me, never mark an angle of depression. You will always mark it as an angle of elevation. The nut, pretend there's a worm in the nut looking up at the squirrel. That angle of elevation will always be the same as the squirrel's angle of depression. Mark it inside the triangle. Okay, what do I want to know? Find the distance from the nut to the base of the tree. Does that picture make sense to you? Okay, we need an equation now. You're going to use sine, cosine, or tangent, and it's going to depend totally on which sides are involved in the problem. Opposite, adjacent, hypotenuse. Which sides are in the problem? Opposite and adjacent. So this is going to be a tangent. So we're going to say tan angle. So tan 23. It's always tangent angle equals opposite over adjacent. Everybody okay with that's the opposite side and this is the adjacent side? So you're going to go ahead, get rid of the fraction, and then divide. So are you dividing 52 by tan 23? 52 divided by tangent 23. And I got that distance to be 122.50. Is it feet? I need a unit on it. Feet, yep. Everybody okay? All right, let's try the next one. Now we got a seagull on top of the lighthouse. And he's looking at a fish. So here's the seagull on top of the lighthouse looking down at the fish. The gull is 87 feet above the water, so that's 87. The gull is 230 feet from the fish. Where does that 230 go? The seagull is 230 feet from the fish. Hypotenuse. Don't overthink it. There's the bird, there's the fish. That's the distance between them. Find the angle of depression from the gull to the fish. Now, technically, this is what you're looking for. But we said we're always going to put it in our triangle. So this is our theta, or our x. I don't care what letter you use. That's your variable. You're looking for the angle this time. You are going to set up an equation using either sine, cosine, or tangent, depending on the sides. Which function are you going to use? Sine. Why? Because that's the angle opposite hypotenuse. So you're going to say sine angle. The angle is always hooked to the sine. So sine angle equals 87 over 230. This is something new.
Since I wasn't here, what does that like symbol mean? Is that basically
It's just a variable.
Just a variable.
It's a Greek letter. Theta. So to get theta now, we're going to do the inverse of the sine. Whenever you are solving for an angle, when your variable is an angle, you have to use the inverse of the sine. If you know the angle, you use a regular function, tan 23. If you don't know the angle, you have to use the inverse. So on your calculator, you'll press secant sine 87 divided by 230, and that angle is 22.23 degrees. So when do I use my inverse functions, secant sine? When my variable is an angle. If your variable is an angle, it's secant sine or secant cosine or secant tangent. Okay, this is the lunch period today. Okay. Let's do one more, or a couple more. Let's finish this section. We can do it, it'll be quick. How far is an airplane from the airport if it is currently 5,000 feet above the ground and the angle of depression to the airport is 17 degrees? Okay, so here's my plane, and here's the airport. Okay, the plane's coming in, he's going to land at the airport. He is 5,000 feet above the ground, and the angle of depression is 17 degrees. So again, technically up here, but I'm going to mark it down here as an angle of elevation. How far is the plane from the airport? So where is my x going to go? On the hypotenuse. Oh, is this kind of the same thing we just did? Your equation will be sine 17, sine angle, equals 5,000 over x. Is everybody okay with my choice of sine? So x sine 17 equals 5,000, and x equals 5,000 over sine 17. Now, you're not using your second button. You're not doing this stuff because you know your angle. You're using regular sine. 5,000 divided by sine 17, and I got 17,101.52 feet. Is that right?
Yep.
Okay, hang on. Hang with me here. Let's do these last two. They're easy. You got it. Find the height of a flagpole that makes a shadow 13 feet long. I'm putting the shadow down here. Does that make sense? Where do we see shadows? On the ground, right? Okay. When the angle of elevation of the sun is 59 degrees. We wanna find the height of the flagpole. Does that picture make sense? Give me an
I have a
equation.
question.
Yes. What?
So does the angle change if it says like elevation or depression, or is it just in the same place?
You're putting them in the same place. The angle of depression is technically up here. That's not even in my triangle, so I put it down here in the alternate interior position.
But it says elevation, so is that?
That
there a
is
difference
literally
between
the angle of elevation. That's the
Okay.
angle of elevation. All right, I need an equation. What's my equation? Tangent. So tan 59 equals x over 13. And we'll just multiply by 13. So this is an easy one. 13 tan 59. Nothing fancy about that. And our answer is 21.64 feet. All right, one more. What is the angle of elevation of a man looking at the top of a building that is 48 feet tall if he is standing 100 feet from it? So here's the man, and he's looking up at the top of the building, and we want to know the angle of elevation. And the building is 48 feet tall, and the man is standing 100 feet from the building. Where does the 100 go? On the bottom. Measured 100 feet from the building, you would measure it on the ground, right? Okay, I need an equation. Love it. Tan x equals 48 over 100. When I type this into my calculator, since the variable is an angle, I'm going to have to do secant tangent. So x equals secant tangent 48 over 100. Secant tangent 48 divided by 100. 25.64 degrees. Everybody okay with that? Perfect. All right, so I think that wraps up 4-2. So 4-2 homework will be due, what is it, Tuesday on Thursday? Okay, 4-2 on Thursday. All right, let's go get you some lunch, and let's be back at, I don't know why this is always so confusing to me. Let's be back at 27. Be back at 27. Okay? Everybody back at 27.
We have to sign out.
Yep, you gotta sign out right there. And sign back in, not my rule, that's the school rule. I've been great. How you been, Jesus? Trying to keep track of where all my kids are. I know. So glad you came back. Okay, so this was.
What are you doing?
I'll show you my money and then
I can have full choice of food. You had to go get me food.
Miss a girl in my car.
What time do we join back?
27.
So it's down so much of food. Down to cheap.
Isn't it Harrison?
Wait,
Obviously.
at your mouse.
If they,
It's just like all this sweater put on black.
y'all ready for to vouch for me?
Let's turn this off. We don't need video all this.
Just tell them